Okay. I have a problem that says a box weighing 450 newtons is pulled along a level floor. At a constant speed. Okay. By a rope at an angle of 30 degrees with the floor. Okay. If the force on the rope is 260 newtons, A, what is the horizontal component? And B, what's the normal? And C, what's the coefficient of sliding friction? Okay? Now, this case is just a little bit different. Okay? Because in this case, we have an object sitting on a floor, and it is being pulled with an angle of, what I say, 30 degrees. So this is a combination of what we did before, okay? The applied force here the applied force here is, did I leave something out? 260 newtons? Yeah, okay. That's 260 newtons. Now, it's at a constant speed, so it's not accelerating, okay? But if this is at an angle, and we did this before when we were talking about walking somewhere or velocities, and we did vector addition or vector resolution, okay? Remember getting the x and y of a vector that was at an angle? We're going to do the same thing here, okay? We need to know what component of that force is Fx, okay? And Fx is going to be, we said this was 30 degrees, and we also have to find out what the component of Fy is, okay? Fx is the adjacent side to that angle. So Fx is going to be the cosine of 30 degrees times the hypotenuse, which is 260. Fy is the opposite. So we're going to say the sine of 30 degrees times 260 newtons. Okay? Which one of these two things is actually pulling it across the floor? The x or the y? The x, okay? So this is the actual one that's doing the pulling. Now to find the normal in this one, we have to consider a different case. For your cases, we're going to look at this one right here, okay? The normal is no longer equal to the weight. Why? Because you have this component, the Vy, vertical one, that is acting opposite, or it's acting in the same direction as the normal. Okay? So actually what you're going to say is it's going to be Fv subtracted from FW, the weight, to get the normal. Okay? So we have to have that too. So let's just plug these in and say Fx, which is just the horizontal one, that's Fx. And Fy is going to be the sine of 30 times 260. Or 130 newtons. Okay. Here's your normal. And that's your FW. And this is your normal. We were given FW in the problem. Right there. 450. Okay. So, to get the normal, we're going to have to say the weight minus Fy. So 450 newtons minus 130 newtons is going to give me my normal. Okay. Let me come out a little bit, just a little bit. Okay. So 450 minus 130 gives me 320. That's my normal. Okay? What are we looking for? We've got to have the coefficient of friction. We need to know what the normal is. Well, we just solved for B right there. Right here. It's a 320. We found the horizontal component to be 225 newtons. So this was A. Okay, is it going at a constant speed or accelerating? Constant speed, so there's no acceleration, right? So that means that Fx is equal to the friction force. Okay? So we're going to say, if we want to know the coefficient of friction, we found the normal to be 320 newtons. The friction force is going to be equal to, but opposite, the horizontal component. So we say 225. Can you see that down there? We say 225 divided by 320. The friction force, or the coefficient of friction, is 0.703. Now, y'all, it's vitally important that you're paying attention and that you keep up with me, because there are going to be times when there's acceleration, there's going to be times when it's not. There's going to be times when we're pulling it and when we're pushing the object. And that means you get the normal in a different way. Okay? If we're pushing, as in this case, you add FV and FW to get the normal, because they're both going the same direction. Okay? If you're accelerating, you've got a net force. If you don't, you're not. And your FF and your FX will be equal. And that's how you get your coefficient of friction. Okay? So, there's going to be several different cases